Hi everyone, it's Alice here from Top Mark Science, and today we're going to be looking at isotopes and ions. Before you get started, you will find it useful to have a periodic table to hand to help you along the way. Throughout this video, we'll be exploring what isotopes are and some examples, the difference between atoms and ions, and how to draw ions using electron arrangements. Let's get started. If you've watched my other videos, you'll know that stuff is made of atoms, and these atoms contain protons and neutrons in the nucleus, and electrons which orbit the nucleus in their shells or energy levels. Pause the video here and spot the differences between the atoms on the screen. If you finish, try the challenge. Let's check to see what we found. All these atoms have the same number of protons and the same number of electrons. This makes them the same element, but they have a different number of neutrons. Atoms of the same element with a different number of neutrons are what we call isotopes. The challenge task will build on this and possibly link back to some prior knowledge. This element is hydrogen. Going from left to right, the first has an atomic number of 1, aka 1 proton in its nucleus, and an atomic mass of 1, only 1 proton in its nucleus. The middle atom is still hydrogen, but another version, an isotope. It still only has 1 atomic number of 1, or the proton number, but an atomic mass of 2, meaning it has 1 proton and 1 neutron in its nucleus. And on the right is another hydrogen isotope that has 2 neutrons in its nucleus. Carbon is another example of an element that can exist in different forms as carbon-12, carbon-13, and 14. They all have 6 protons, but different numbers of neutrons. Excellent, that's isotopes covered then. Taking a step back to move forwards now, our basic structure of an atom. Remember my atoms video? The number of protons equals the number of electrons in an atom, which means the number of positive charges equals the number of negative charges. They balance out, giving an atom an overall neutral charge of 0. These electrons orbit the nucleus in shells, following our 2 key rules. So this atom has 2 electrons on the inner shell and is in group 6. So it has 6 electrons on its valence shell. When this atom reacts with another, this shell can fill up to 8 to make it stable. A stable atom is a happy atom. In this case, it needs to gain 2 electrons from elsewhere. This is where ions come in. No, not ions, ions. An ion is an atom that has gained or lost electrons to become charged. So, to reiterate, with this group 6 atom, it needs to fill from 6 to 8 to become stable. So it gains 2 electrons. Just a quick note to say that electrons you add should be different to the original electrons to show they have come from somewhere else in a chemical reaction. I would recommend using dots and crosses. Each electron is a negative charge. So by gaining 2 electrons, mean the ion will have a charge of -2. And finish off with brackets on your diagram. Let's look at another example. This atom is in group 7 with 7 electrons in its valence shell. To become stable, it needs 8. So it needs to gain 1 electron, shown by this cross, which means it gains 1 negative charge. Finish off with brackets and a charge. A quick pause here. What needs to happen to this sodium atom to get a full outer shell? Let's see what we've come up with then. This atom is in group 1. So it has 1 valence electron. Now there are 2 possibilities. It could gain 7 electrons to make the valence shell up to 8, or lose 1. Now it's way easier to lose 1 electron. So that's what it does. So we no longer need this shell. By losing this 1 electron, it has lost 1 negative charge, leaving the ion with more positive protons. So it becomes a 1 positive charge. That's the key here. Ions are charged and have full shells. Pause the video here and fill the boxes to complete the table to determine the charge of each ion. If you finish, try the challenge. Use a periodic table to help you. Let's go through some answers. Marking pens ready. Chlorine is in group 7, so it has 7 valence electrons. So it needs to gain 1 electron to add up to a happy and stable 8. Gaining 1 negative electron leaves the ion with a negative 1 charge. Sulfur is in group 6, so it has 6 valence electrons. To add up to 8, it needs to gain 2 electrons, giving it a negative 2 charge. Beryllium is in group 2, with 2 valence electrons, so it will lose these 2. By losing electrons, you are losing negative charges and becoming more positive, so this ion becomes a +2. Same for magnesium, and aluminium becoming +3. If you did the challenge, you may have spotted that group number is linked to the charge of an ion. For example, group 1 elements form +1 ions, group 2 form +2, etc. When you get to the non-metals, they become negatives that should add up to 8. And metals lose electrons, whereas non-metals gain electrons. Well done, everyone. Let's look at drawing ions then. I will start with some examples, then you will have some time to practice. I will start with sodium, the atom shown here. Just to quickly recap, feel free to follow along with the periodic table. It's in period 3, so it has 3 shells, as in group 1, so it has 1 electron in its valence shell. I've filled in the rest using the 288 rule. Now I will decide what happens to make this stable, in other words, have a full outer shell. So it will either gain 7 electrons or lose 1. Spoiler alert, it loses. The metals always lose their valence electrons. So we no longer need that shell. Here I've drawn it without. And I put in my brackets. And I place my charge. 1 electron has been lost, which means a +1 charge. Can also be written as a symbol like below. Pause the video here and use what you've just learnt to draw the ions formed for the following atoms. If you finish, try the challenge. If you need to see the example again, it's on the screen, or replay the video. Use a periodic table to help you. Let's mark our work. Marking pens ready, everyone? Lithium is in period 2 with 2 shells, and group 1, so 1 valence electron. Fill up using the 288 rule. Lithium will lose this 1 valence electron to become stable, so we no longer need this outer shell. Remember your brackets and a positive charge. Remember, we have lost a negative charge, so we're more positive now. Next up, oxygen. In period 2, group 6. Fill up the other shells. Now these 6 electrons need to become 8, so we gain 2 electrons. We draw them on using crosses and add our brackets and our charge. It's a -2 because we have gained 2 negative electrons. It doesn't matter if you write -2 or 2 negative, although you will see it written more as I have on the screen. I'll put the rest on the screen now. You might find it useful to pause here so you have time to see them all. And here they are, the remaining ions. Finally, time for our end of video quiz. Let's see what we know. Question 1. An isotope is an atom of the same element with a different number of bonus points for an example. Neutrons. Bonus points for isotope examples, hydrogen and carbon. Question number 2. When an atom gains or loses electrons, it becomes an ion. Well done. Question 3. True or false? When atoms gain electrons, they become negative. This is true. By gaining electrons, we gain more negative charges. Question 4. Atoms are most stable when they have how many electrons on their valence shell? They are most stable when they have 2 on their inner shell and 8 on their outer shells. Final question. What would the charge be of a calcium ion? Calcium is in group 2, so it has 2 electrons in its outer shell. Therefore, it would lose these 2 electrons and become a 2+ ion. Really fantastic work today, everyone. Take the time now to see where you might be for each objective. Remember to be honest with yourself. Thank you so much for watching this video, guys. If you enjoyed it and would like to see more from Top Mark Science, you can like this video and subscribe to this channel. I'll see you next time.